Alright, my dear children, we will continue again writing the displacement equation of plane progression in harmonic motion. Okay. Now, in the last YouTube video, we had done up to this relation when displacement of the particle, okay, in a plane progressive harmonic motion along positive direction x-axis is given by y equals to a sine bracket omega t minus kx, where k is considered as propagation constant. Now, this equation is basically in terms of angular frequency. But the same relation, children, we can write in terms of time period. And in case, of course, we can write the displacement equation in terms of wavelength. In terms of what? Wavelength. So for that, let me just write that angular frequency, as you know, it's equals to 2 pi by what? T. See, time period can be written in terms of angular frequency. Means omega means angular frequency equals to 2 pi by T. And in the last YouTube video, you learned that this k is actually 2 pi by what? Lambda. This k is a what constant? Propagation constant. So now I replace this omega by 2 pi by t and k as 2 pi by lambda. So let me write down now y equals to a sine omega. Omega I write down as 2 pi by what? T and small letter t, okay, minus k means what? 2 pi by lambda, and this is what? X. Okay, 2 pi by lambda, and this is x. Now in the relation I can take common. So common is 2 pi. So let me just take common 2 pi. Sine, I write on 2 pi. And write in bracket smaller t by capital T minus x by lambda. So we got another important relation that measure the displacement of particle in plane progressive harmonic wave. This is for positive direction x-axis. This is for what? Positive direction. Positive direction. Okay, this is for positive direction of which axis? X-axis. So when a wave propagates in the positive direction x-axis, then we can even write the displacement equation in terms of time period, t means time period, and the wavelength of the wave as y equals to a sine 2 pi bracket t by capital T minus x by what? Lambda. Now children, the same relation I can even write in terms of I can write when the particles are propagating along negative direction x-axis also. So I write on if the wave propagates, if the wave what? Propagates along what? Negative direction, along negative direction of what axis? X-axis. So the same relation we can write as y equals to a sine 2 pi bracket t by capital T, but with what sign? Plus sign, and then plus x by lambda. So for negative x-axis, direction x-axis, the wave equation, the displacement equation of plane progressive harmonic wave can be written by this. But these two relations which I have written is in terms of time period and the wavelength. Time period and the what? Wavelength. Now we write again the relation. We again write the relation, but in terms of the speed of the wave or the velocity of the wave. So we can even write the relation in terms of speed of the wave or the velocity of what? Wave. Now in order to write the relation in terms of speed of the wave, so we know, children, in wave equation or wave motion, the three parameter frequency, time, frequency, speed, and the wavelength, they are always interrelated to each other. And the relation that we have already derived is that speed equals to frequency, which n into lambda. Yes, speed equals to frequency into lambda. Then frequency equals to speed by lambda. But even you know, children, that frequency is also 1 by t. Frequency and time period are reciprocal to each other, which means I write on 1 by t is also equals to b by lambda. 1 by t is also equals to b by what? Lambda. So 1 by t is in the expression of this displacement. So now I replace 1 by t by b by lambda. So you can see the relation will be further written as y equals to a sine, okay, a sine, okay, let me write 2 pi, this is 2 pi, bracket, small t is there, but 1 by t is there, 1 by t I write down as b by lambda into what? T. I hope you understood. This 1 by t I replace by b by lambda, and there is already t minus x by what? Lambda. X by what? Lambda. So in this relation, if you see, we can take lambda as a common. Yes. So A sine 2 pi by, yes, lambda I'll take take common from this bracket. So it will be inside the bracket bt minus what? X. So look at the relation. Yes, y equals to A sine 2 pi by lambda bracket bt minus x. And this is also the displacement equation of the particle in plane progressive harmonic wave, but in terms of what? The wave speed. We also call the velocity of wave or wave speed also. But this is true for what? Positive direction x-axis. This is for positive direction of x-axis. Means when the wave propagate along positive direction x-axis. Now if the wave can propagate along negative direction x-axis, we write the same relation but with what sign? Plus sign. Therefore, the same relation now I can write for negative direction x-axis. Means if the wave propagate along negative direction x-axis. So y is also written as A sine 2 pi by what? Lambda bt plus x. Just you need to put a plus sign. Now just see how many equations that I derive. So total 3 equations I derive. Okay, for the wave, plane progressive harmonic wave which are traveling along the positive direction x-axis, and also 3 equations I derive for plane progressive wave traveling along the negative direction x-axis. So I did for both positive and negative direction what? X-axis. So this bracket equation which I have derived, these are all the displacement equation of plane progressive wave traveling along positive direction as well as negative direction x-axis. But we derive in terms of angular frequency, we derive in terms of the time period and wavelength, we even derive in terms of the wave speed. And these equations are important, okay, and will be asked in the examination also. Now in the next YouTube video, we basically learn a topic called phase and phase difference. And from there we derive a relation, okay, between phase, even a relation between a velocity called particle velocity and wave velocity. Okay, so these are the topic that you learn in the next videos.